So today our learning intention is to learn about families of the straight lines and linear models. So families of the straight line. When we say about anything family, what does it mean?
Related groups.
There is some relation between them. There is something in common. So one with the straight lines, because equation of the straight line y equal mx plus c. What can be common between straight lines?
Gradient.
Can be gradient or y-intercept. So today we're looking only into the families of the line which has same y-intercept. The families of the functions with the same gradient we will look on Thursday. Today we're looking to this. So for example, we have, so lines have same y-intercept. If you look on the possible graph, let's say C equals 3. Then any line going through 0, 3 is a member of this family. All those straight lines have in common that they have same y coefficient. They have in common same y-intercept. So it will be y equal 5, for example, 5x plus 3, y equal minus 7x plus 3. Common between them is that they all have the same y-intercept. Example. Let's say family of lines has equation that is from exercise 2F, question 8. A family of lines have equation of the form 3x plus by equals 12, where b is non-zero number. Find the y-axis intercept in terms of b. How we find in y-intercept? We take x equals 0. So we get by equals 12, y equals 12 on b. We found the y-axis intercept in terms of find the gradient. How we find the gradient? What we need to do to find the gradient of this line? Rearrange it to make it in the form y equal mx plus c. So we will get from here by equal 12 minus 3x. So y equals negative 3 on b. X plus 12 on b. So what the gradient is?
3 over negative 3.
Negative 3 over b. Equals negative 3
b's
on b. And then find the value of b if the gradient is negative 2. Easy peasy. Negative 3 on b equal negative 2. So b will be equal, will be 3 over 2. And the last part D, as find the equation of the line which is perpendicular to the 3x plus by equals 12 at the point 4, 0. So we know that the gradient of the line is -3 on B. So what the equation, or what are the gradient of the perpendicular line? -3 on B times M1 is to be equal -1, so M perpendicular, M perpendicular equal +3.
No, what? Yeah, B over 3.
Yeah.
Yeah, we have M perpendicular will be positive B over 3. So what the equation of the line? From here, M1 minus cancels out, B there, 3 there, B on 3. So Y equal B on 3x plus C. And we have the point for 0. We have point for 0, we have 0 equal B on 3 times 4 plus C. So C will be equal -4B on 3. So equation is Y equal B on 3x minus 4B on 3. Make sense?
Yeah.
Just an example. That's pretty much how you deal with the families of the straight line which has common y-intercept. There is much more to the case when they have same gradient, but that we'll look into this on Thursday. Linear models. There are a lot of situations which we can model with the linear equations. And one of them, one type of those models is motion. Let's say we have two towns, A and B. And we have one car moved, let's say car and a bus. So car moves with a distance between A and B. Let's say will be 300 kilometers. The car moving from A towards B with a speed, let's say 80 kilometers per hour. And there is a bus moving from B to A with a speed, let's say 70 kilometers per hour. Question is, first, how long it will take them to meet? How long it? Yeah.
2 hours.
Yeah, it will be 2 hours. But how we can find that mathematically? So we have, let's write down the equation where x will be, let's take this 0 here, and the x going this way. And what will be the equation of the position of the car at any given time? It starts from 0, we take 0 here.
80 t.
And time is t, so its position will be equal 80 times t. Does that make sense? That x position of the car moving from A, where its position we take 0 at 8. So at any given time, its position will be 80, its speed times time. Make sense? Now, what will be, this is equation x car. X bus. What will be equation of the motion of the bus?
70 t.
300 minus 70.
300 minus 70.
Oh yeah. Please.
Why 300? Because when time equals 0, it is not at A. It is 300 away. So it starts from 300. Why minus?
Because it's going backwards.
So it's going backwards. So that is model equation that model in motion of the car, and this is the equation that model in motion of the bus. When they meet, what we can say about their position? X will be the same. So we equalize them, just 80t equals 300 minus 70t, and obviously t equals 2 hours. And if the question will be how far from A they will meet, what we should do?
160 kilometers.
Sub in 2 to one of them, so we have x car equal 80 times 2 equal 160 kilometers. Make sense? Now, another question on the motion. If we have two, again, car and a bus, start from town A, and bus moving with a speed, let's say 80 kilometers per hour, that way. The car started, I'll put T0, 2 hours after the bus, in the same direction. So now they're moving in the same direction, but they did not start at the same time. Bus already moving for 2 hours when car starts, but car moving at let's say 100 kilometers per hour. How long it will take car to catch up the bus? So we need to again write down the equation of the motion of each of them.
Silly guy.
So x of bus will be equal, what will be equation for the bus?
80t.
80 times t. What will be the equation of the motion of the car? 100 times t minus 2.
Yeah.
Because it starts 2 hours later. T minus 2. Does that make sense? That
Yes.
that will represent that it started 2 hours later. It's time, it's moving 2 hours less. Then when they catch up, we equalize 80t equal 100, t minus 2, we can cancel, and then we can divide, even simplify more, so divide by 2, so we have 4t equals 5t minus 2, with the expanded brackets, we will get that t equals
10.
10. Is it correct?
Yes.
4t equals 5t minus 10, 10t equals 10 hours.
Yeah.
So it will take 10 hours
Is that?
to,
How does that work?
No,
Because after it travels for 2 hours, it's 160 ahead, and every hour it goes ahead 2. So
And
every
it
so it
is
should only
catching
take
up.
8 hours.
so it
You have to take time from when the train stops.
160, 2 hours, it will be already 160 ahead, and then every hour,
It goes 2 closer. The car gets closer by 2 every hour. So it shouldn't only be 8 hours?
so let's see if
It's
we
8
can
hours for the car.
Oh, it's
But
8
10
hours
hours in
after the
total.
bus leaves
No,
and
it's,
catches up to 8 hours
sorry.
after the
It's
car
10,
leaves.
10 hours after the bus.
Yeah, 8 hours
So
after the car.
for,
How much time
for,
from the bus
for
start?
car, it will be 4 hours, sorry,
If the bus
for
start-
car it will be
Yeah,
8 hours.
Yeah.
But when the bus starts, it will be, from point the bus, it's 10 hours, from when car starts, it's 8 hours. And one more example on the linear models. On the linear models, it will be from textbook. That will be exercise 2G, question 10. 2G, question 10. Electronic bank teller registered $775. After counted 120 notes, and then after counted 160 notes, there are $975. $975. Find the formula for the sum, C, so that's C, and number of notes. Notes are the same. Otherwise, it will be not enough information. How we can write the equation that will relate number of the notes?
120n equals 775.
So we have 2 points. It's a linear relation. 1 point, 120, 775, and second point, 160, 975. We need to find equation going through these 2 points. What is the gradient? 200 over 40. So equation C equals mn plus, not C, we already have C, plus D. We found that gradient equal to 100 over 40 is 5. You substitute 1 point. Can you see from there?
Yeah, kind of.
So then we have a substitute, we have C equal 5 times number of notes plus D. You substitute 1 point, let's say 120, 775 equal 5 times 120 plus D. So 600, so D equals 175. So D equals 175, and equation is C equal 5n plus 175. Makes sense how we found the equation? We identified the information given it's at 2 points, and we can calculate. That's question A. Question B, asking, was there a sum already on the register when counting begin?
175.
We already found answer at 175, and we answered C, if so, how much? 175. So those are just an examples of linear models. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, etc. Support Ukraine and Israel.